Hi class, congratulations. You have successfully made it to your last video of this chapter. We are on 2.9. Our last function is called the square root function. So once we're done with this lesson, you're going to get a review, and shortly after that you're going to take a test. So make sure that you prepare yourself. Very shortly we're going to have a test on all of the linear functions that we've been talking about with y equals mx plus b, y minus y1 equals m times the quantity x minus x1, standard form. We're going to have the square root function, the absolute value function, inequalities. So make sure that you're refreshing yourself on all those. Today is the square root function. So if we look at our first one, we see graph y squared equals x. Now when we say graph this function, oftentimes I think the first thing we think of is let's put this into our graphing calculator. And that is a good thought. Oftentimes when we're in this class, to get a good picture of what the graph looks like, technology is a wonderful tool. It's a great idea to put this into our calculator. However, our calculator only graphs y equals equations. So I have to get this to be a y equals equation. So back in Algebra 1, you learned how to get rid of this square sign. I want to get y all by itself. Right now it's y squared. So to get rid of that square sign, I have to take the square root of it. So what I do to one side, I have to do the other side. So I'm taking the square root of both sides. So the square root of y squared is y. That equals the square root of x. Now another thing that you learned back in Algebra 1 was that when you take the square root of both sides, you have to have a plus and minus right there. If you have x squared equals 9, x equals not only 3, but it's plus and minus 3. Because a negative 3 squared is 9, as well as a positive 3 squared is 9. So that's why you need to have both the plus and the minus. However, for this lesson, the only one that we're going to talk about, and on the test, the only thing that we're going to worry about is the positive. So we're just going to say y equals the square root of x. Now this class we can put in our calculator and get the correct answer. However, I just want to use a little bit of mental math before we do that into our calculator. If I want to get a good picture of what this looks like, what I'm going to do is I'm just going to pick some points. And they're not going to be random points. They're going to be strategic points. Think to yourself what I like to call convenient points. What would be nice points that I could plot somewhere on this graph to make a function? What I mean by that is this, class. I want to put in a value for x that's a convenient point. An inconvenient point might be putting in 3 in for x. If I put 3 in for x, I would have to say, okay, what is the square root of 3? And I get 1.7 something. That's not very convenient for me. However, if I put in maybe the square root of, just for convenience, we'll start off with 0. What is the square root of 0? Well, 0 times 0 is 0, so the square root of 0 is 0. So if I put in a 0 in for x, what y value do I get? Y would then equal the square root of 0, which would then be y equals 0. So when x is 0, y is 0. Easy enough. Let's ask ourselves another question. Let's put in another convenient point. The square root of, let's say, 1. We know what the square root of 1 is. If x equals 1, then we would say y equals the square root of 1. And what is the square root of 1? Obviously, it is 1. 1 times 1 is 1, so the square root of 1 is 1. Let's try another convenient point. I'm not going to substitute in 2 for x. That would be just silly because that wouldn't come out to be a nice number. I wouldn't substitute in 3 in for x like we talked about. That wouldn't work too well. Could I substitute in 4 for x? Bam! I got myself another convenient point, do I not? If 4 is substituted in for x, then I would say y equals the square root of x, which is the number 4. And what is the square root of 4? 2 times 2 is 4. So y equals, what am I doing here? If y equals the square root of 4, then y would equal, obviously, a 2. And there we have it. You've successfully picked 3 convenient points for yourself without using a graphing calculator, which I think is very valuable. So we're going to substitute these 3 points, or we're going to plot these 3 points onto our XY coordinate grid. 0, 0, 1, 1, 4, 2. 0, 0. Right 1, up 1. Right 4, up 2. And here you have a nice picture of the square root function. Now class, if you would like to, if you don't want to use all this mental math, I have no problem if you just put these in on your calculator. But here's how I want you to do it on your calculator, so pay very close attention. This is what I want to see on a test. If you put it into your calculator, you're going to go to y equals, the top left button. You get a bunch of y1, y2, y3, so on and so forth. Under y1, you're going to put y equals the square root, which you go to second, the squared button. That's the square root. Second square root of x. Close your parenthesis. And we press graph. Doesn't that line look a lot like the one that we did on our own? Hopefully you say yes. Now what I want you to do is, if you do this in your calculator on a test, I don't just want you to write a line that looks like this. Okay? That would be just silly. What I want you to do is I want you to put 3 points somewhere on your graph. 3 or 4, it all depends you know how much graph paper you're given. But the way you do that is you go to the table again, like we've talked about in other lessons, which is the second graph button. That's the table. You can see that we have a bunch of errors as we go -1, -2, -3, -4. That is the reason for that is that you can't take the square root of a negative number. I'm sure you guys have been introduced to that before. It's impossible to get a square root of a negative number, so it has to start at the positive numbers. So as you can see, it does start at 0, 0, 1, 1. Here's our 4, 2. So these 3 points are the ones that we put in on our own. We said that we were going to skip 2 and 3 because look at how yucky these numbers are. 1.4142, 1.7321. Those just aren't very convenient numbers to plot. So if you do use your calculator, I want you to go to the table and I want you to plot these convenient points that are given in your table. Okay, make sure that you do that. And just as we've done it on ours, 0, 0, 1, 1, 4, 2. I hope that makes sense about what I expect from you on your graph. I really want 3 or 4 points on your graph, which we're going to have 3 more practice problems discussing that more in depth. All right, let's talk about the domain and the range. Let's pull up our vertical and horizontal lines here. All right, so if I have my vertical line here, I'm going to do the domain first. So I ask you this question: do I touch any red from left to right, any red, any red? Right there is when I start, correct? And where do I stop? I'm starting at 0, and I end at, it's going to go forever and ever and ever to the right, isn't it? I could put in 7, I could put in 10, I could put in 100, I could put in 1,000 for x. I could put in any number for x. It doesn't matter. I could put it all the way up to infinity. So for my interval notation, I start at 0. Now I ask you this question: can I put in 0, or is it just right above 0? I'm asking you, should I put in a parenthesis or should I put in a bracket? It is equal to 0. I can put in a 0 here. I already did. The square root of 0 is 0. So because I am able to put in a 0 there, I'm starting at 0, and it also includes 0. So I bracket that. And then how far to the right does it go? It goes all the way to positive infinity. And infinity is always followed with a parenthesis. So there's my domain for interval notation. Let's talk about my domain for set notation. It's everything from 0 to the right. From 0 all the way to the right is my x's. And all the way to the right is greater than. It's bigger. It's further to the right of 0. So we say x such that x is greater than or equal to 0. Make sure you have that greater than or equal to. If you just have greater than on a test, I will have to take off half of a point. So make sure you have that greater than or equal to sign, because it can equal 0. This function does exist when x equals 0, so it could equal 0. All right, there's our set notation domain. Let's talk about our range. So we're going to take this line right here, and let's put it horizontal. Now, you don't see it touching any red, any red, any red, any red until right there again, right? This red line goes all the way down to the origin. So once again, it starts at 0. Now, how high does it go? This could be a little bit trickier. If you think about it this way, if I put in, 1, I get 1. If I put in 4, I get 2. Another example, if I put in 9, so here's 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just say, for example, I put in 9 for x. So x equals 9. The square root of 9 is 3. So if I put in 9, I would get a value of 3. So then it would even get higher yet. If I put in a value of 16, my y value would be 4. Then it would get higher yet. If I put in 25 for x, my y value would be 5. It keeps on getting higher and higher and higher and higher. The higher the x values you put in, the higher the y values you get. So if it's infinity for x, for those values, your graph is just going to continue getting higher and higher and higher and higher. It keeps on going up and up and up to the right, to the right, to the right. So if that's the case, it goes all the way up to infinity. That is how high your graph goes. So once again, we're going to start at 0 for a y value, and you're going to go all the way to positive infinity. And once again, it includes 0. You can have a y value of 0. So because that is the case, we use a bracket here. And then the set notation is the exact same for the domain as it is for the range, because you start at 0 and it's everything greater than or equal to 0, because it's everything above that. That's where my y values go. So we're going to have y such that y is greater than or equal to 0. All right, there is your first square root problem. We're going to have 3 more for practice, but just in summary, what I expect from you on the graph, I expect you to have 3 or 4 convenient points, okay, and connecting those dots with more of a curved line, as well as I expect the domain and range from you in set notation, as well as the domain and the range from you in interval notation. You can use your calculator, in which case you don't need to use this table. However, if you don't use the table, you just use your calculator, I need to see 3 distinct points here. If you just try to look at your calculator and try to approximate where it is on the graph and draw a line that might look like it, I'm not going to give you full credit unless I see this point, and this point. Am I clear on that? I hope I am. All right, number 2. This one says y equals the square root of x, and then we're going to add 3 more to it. You can put this in on your calculator. Let's all do it together, though, by using an XY chart. So once again, I'm going to put in convenient values. I'm not going to put in inconvenient ones. We already talked about some of the convenient ones, the square root of 0, the square root of 1, the square root of 4, the square root of 9. So let's put in 0, 1, 4, and 9. Because we know those are good values to use when we have the square root function. So if it's the square root of 0, which is 0, so y equals 0 plus 3. So what does y equal when we put 0 in for x? 0 plus 3 is 3. So y would then equal 3. Let's do this for the other 3 points. If we put in 1 for the square root of x, so now it's the square root of 1, which is 1, and 1 plus 3 is 4. Let's do it 2 more times for 4 and for 9. The square root of x, which we're putting in 4, so the square root of 4 is 2. And 2 plus 3 is 5. And last one, we got our 9er. So the square root of 9 is 3, and 3 plus 3 is 6. So as you can kind of see, it goes by pretty quick. You could almost do this just as fast as you can punch it into your calculator, look at the table, and pick some points there. So you can use your calculator, or you can pick convenient points. All right, let's put these on our graph. 0, 3, 1, 4, 4, 5, 9, 6. 0, 3, 1, 4, 4, 5, 9, 6. 4, 5, and 9, 6 is off our graph, but it's somewhere like here, I suppose. So then we're going to Connect these with a curved line as we go up and to the right. All right, that's what I expect from you on the graph. Let's talk about the domain and range for interval and set notation. Should have had this line up here earlier. As I go to the right, it starts at 0. And how far does it go to the right? That arrow tells me it goes to positive infinity. So it starts at 0, and it ends all the way at positive infinity. Parenthesis after positive infinity, we're going to have a bracket here because I can have an x value of 0. It's right there. So it's possible that x can equal 0, so I bracket that. So then I have x such that x is greater than or equal to 0. If it's to the right of 0, it's bigger than it, it's greater than. For my range, I'm going to make a horizontal line here. As I go up, it starts at 3, doesn't it, for a y value. And then this arrow goes up and to the right, so it goes up and up and up all the way to positive infinity. So it starts at 3, and it goes to positive infinity. Now it starts at 3, and it can equal 3. Y equals 3 right there. So I know that because it can equal 3, I bracket that. So for my range, y such that y is everything greater than or equal to then the positive 3. All right, 2 left. Why don't you guys pause the video, try these 2 on your own. Unpausing the video, we got this. Y equals the square root of x plus 3. You can put this into your calculator if you would like to. Another way you can do it is let's just plot some convenient points. Now this one might be a little bit trickier. I want this whole square root to be 0. Because if that whole square root is 0, I know that the square root of 0 is 0. So what would make this whole square root 0? What happened if I put a negative 3 in for x? What's a negative 3 plus 3? Hey-oh! It's 0, isn't it? So if I put in a negative 3 for x, I would then get the square root of 0. And what's the square root of 0? 0. There's one of your convenient points. Boom cha. Your next convenient point. I would want this whole radical sign, this whole thing, to equal 1. Because I know that the square root of 1 is 1. So what would I have to put in for x to make this whole thing equal 1? Your answer is hopefully a negative 2. What's a negative 2 plus 3? 1. And what's the square root of 1? 1. So if I put in a negative 2 for x, my y value that I get is a 1. All right, let's pick 2 more points. I want this whole square root to be the number 4, because I know what the square root of 4 is. So if I get a 4 here, I know that my x value has to be a positive 1. Because 1 plus 3 is 4, and the square root of 4 is 2. So when I put in 1 for x, the y that I get in turn is a 2. Last one, I've done 0, I've done 1, I've done, let's see, the square root of 0, the square root of 1, the square root of 4. I next want the square root of 9. Because if I get this whole square root to be a 9, I can take the square root of 9 and get a convenient number of 3. That would make my x equaling a 6. So if my x is a 6, what is 6 plus 3? 9. And the square root of 9 is 3. Whew! You found your points. Let's put them on our graph. A negative 3, 0, right there. A negative 2, 1, right there. Positive 1, positive 2, right there. And then 6, 1, 2, 3, 4, 5, 6, up 3, 1, 2, 3, right there. So now we have our graph that looks like this. If you want to do it on your calculator, I invite you to do that, class. You're more than welcome to do that. Just make sure you go to the table and pick those convenient points. All right, my domain and my range. Where do my x's start? No x's, no x's, no x's, no x's until right there, which is at a negative 3, correct? Starts at negative 3, and then it goes forever to the right. So I start at -3, and it can equal a -3, so I bracket that, and I go all the way to positive infinity. So I say that x such that x is greater than or equal to a -3. It's everything to the right of -3. So it's greater than it, greater than or equal to. Now I'm going to do this exact same thing with a horizontal line as I go up. No y values, no y values, no y values until right there I have a y value. What y value is that? That point is at -3, 0, so that y value is a 0. So it starts at 0, and how high do I go? My line keeps on going up and up and up, to the right, to the right, to the right, all the way to infinity. So I'm going to start at 0, and I'm going to end at positive infinity. I bracket 0 because it can include 0. So y such that y is greater than or equal to 0. Whew! Last one. We have the square root of x plus 3 minus 5. So once again, class, I'm going to want some convenient points. Those convenient points are when this square root is 0, when that square root is 1, when that square root is 4, and when that square root is 9. Those are the 4 most convenient points. So, what x value should I put in to make this whole thing a 0? And your answer is -3. When I put in a -3 for x, -3 plus 3 is 0. The square of 0 is 0. And then 0 minus 5, my y value ends up being a -5. Let me just write that out one time so you guys can see where I got that. Y equals the square root of x, which we're putting in a 0 for x. Oh, sorry. We're putting in a -3 for x. So y equals the square root of x, which x we're putting in a -3 plus 3, and then we're going to subtract 5. So now simplifying this, a -3 plus 3 is 0, so it's the square root of 0 minus 5. The square root of 0 is 0 minus 5, and then we get a -5. So that's how I got this number. And I'm going to do that exact same thing for 3 more x values. The second x value that we're going to do that one for is going to be whatever makes the square root equal to 1. So what makes this whole square root equal to 1? That's when I put a -2 in here. Because a -2 plus 3 is 1. The square root of 1 is 1. And 1 minus 5 is a -4. Keeping on. We want this whole square root to equal a 4. So we're going to put 1 in here. 1 plus 3 is 4. The square root of 4 is 2. And 2 minus 5 is a -3. So when we put in an x value of 1, we get a y value of a -3. Last one, we want this whole thing to equal a 9. So that means we have to put a 6 in for x. Because 6 plus 3 is 9. And then the square root of 9 is 3. And then 3 minus 5 is a -2. So when we put in 6 for x, we get a -2. All right, let's put these on our graph. Say the domain and the range. A -3, -5. 1, 2, 3, 4, 5. Next one, a -2, -4. Next one, +1, -3. And the last one, right 6 and down 2. And there's your square root function. So the domain, we could probably do this without the vertical line. The domain would start at a -3. And how far does it go to the right? This arrow says it goes for infinity to the right. So it goes all the way to positive infinity. If you've kind of gotten the pattern on all these square root functions, the starting value is always bracketed because it can equal that value. So then it's going to be x such that x is greater than or equal to a -3. So now, talking about the y value, where does my y value start? Nothing here, nothing here, nothing here. My y values start right at this line. which this line is at a negative 1, 2, 3, 4, 5. It starts at a negative 5, and then this green line goes up and up and up and up, and it will go up forever. So that means it goes all the way as high as positive infinity. We bracket my negative 5 because it can equal negative 5. Y, such that y is greater than or equal to then a negative 5. All right. That prepares you for the worksheet, and that prepares you for the test. There is one tricky question on Excel math, and it's one that looks like this. You guys are used to now seeing it look like y equals the square root of x plus 3. If you see x equaling the square root of y plus 3, here's what I suggest you do. Don't put it in your graphing calculator because you're not going to have any success. The skill that I just taught you is let's plot some convenient points. You guys are more than welcome to use your calculator on all 4 of those problems that we did. You can use it on your worksheet, you can use it on the test, and I have no issue with that. But on Excel math, you can't use your graphing calculators when you get to this problem. So let's just put in some convenient points. What happens when y is 0? When y is 0, we have the square root of 0 plus 3. And the square root of 0 is 0. 0 plus 3 is 3. So you've just found a point, and it's convenient, which means there's no decimal, there's no fractions. It's a nice integer number. Let's find out what happens when y is 1. The square root of 1 plus 3. The square root of 1 is 1, and 1 plus 3 is 4. Let's do one more point. Let's do 2 more points. What's better than 1? 2. Let's do what happens when y is 4. What's the square root of 4? It's 2. And what is 2 plus 3? 5. Last one. What happens when y is a 9? When y is a 9, the square root of 9 plus 3 is 3 plus 3, which is 6. So now on Excel math, you're going to have 4 A, B, C, D options, and now it becomes very, very simple. You just pick the one that goes through those 4 points. 3, 0, 4, 1, 5, 4, and then the last one being 6, 9. So that's how you do that one. Most of them, you're going to see like the first 4 that we had, where you can put them into your graphing calculator or pick convenient points. Those are the ones that you're going to see on a test. You might see 1 or 2 problems like this on Excel math. So that's how you do those ones. So your homework is objectives 19 and 20, and those are the last 2 objectives for this chapter. So once you're done with that, make sure that you do the review, and after that, we're going to have a test shortly after. So make sure that you prepare yourself for that. Let me know if you have any questions on any of the lessons that we talked about for Chapter 2.